Have you ever looked at data from a few different groups and just wondered, is the difference I'm seeing real or is it just random noise? Well, today we're going to demystify ANOVA, a super powerful statistical tool that helps you find a real, confident answer. Let's break it down. So, let's make this real. Imagine a professor. They've got 3 different study techniques they want to try out. Some students use method A, some use B, and the rest use C. Then they all take the same exam. Now, if the average scores are different for each group, how does the professor know if it's because the methods actually work differently, or if it was just luck of the draw? How can they find out for sure?
Well, answering that exact question is precisely what ANOVA was designed for. ANOVA, which stands for Analysis of Variance, is the tool you use to compare the averages of 3 or more groups to see if the differences are statistically significant. Basically, it helps you cut through all the random noise to find a true signal.
Okay, so let's start with the most fundamental version. Think of this as the essential go-to tool in your ANOVA toolkit, the one-way ANOVA. You know, the name really says it all here. A one-way ANOVA is all about looking at the impact of just one thing, what we call a factor, on an outcome. So you're changing one variable to see what happens. It's a straight line, one potential cause, one potential effect. What's really clever about ANOVA is how it thinks. It starts off skeptical. It assumes something called the null hypothesis, which is just a fancy way of saying, let's assume there's no difference here and all the group averages are the same. Then the test looks for enough evidence to overturn that assumption and say, actually, you know what? At least one of these groups is not like the others. That's the alternative hypothesis. To make this super clear, let's imagine a farmer. The one factor she's testing is fertilizer mixture. She's got 3 different types. The response she's measuring, that's her crop yield. A one-way ANOVA is the perfect tool to tell her if there's a real, significant difference in how much her crops grow based on the fertilizer she uses.
But let's be real. The world is rarely that simple, right? What happens when you suspect that 2 different things might be influencing your outcome? Well, that's when you need an upgrade. It's time for the two-way ANOVA.
And just like before, the name gives it away. A two-way ANOVA lets you examine the influence of 2 different factors on a single outcome. This is where things get really interesting, because most effects in the real world have more than one cause. Here's the cool part. A two-way ANOVA is incredibly efficient. It's like a 3-for-1 deal. It answers 3 big questions all at once. First, it checks the main effect of your first factor. Then, it checks the main effect of your second factor. And then, it asks the most interesting question of all. Is there an interaction effect happening between them? Let's go back to our farmer. This time, she still wants to test her 3 fertilizer types, but she also suspects that planting her crops farther apart or closer together might make a difference. So now she has 2 factors to test, fertilizer type and planting density. This brings us to the real secret weapon of the two-way ANOVA. It's the most insightful piece of the puzzle, and it's called the interaction effect. So what is an interaction effect? It's what happens when your 2 factors don't just add up nicely. They combine to create a unique result. The effect of factor A actually changes depending on which version of factor B you're looking at. It means they're not acting independently. They're working together, or maybe even against each other.
Honestly, the best analogy for this is cooking. Think about it. Salt has its own flavor. Caramel has its own flavor. But when you combine them, you get salted caramel, a totally new, surprising taste that you couldn't have predicted just by knowing what salt and caramel taste like on their own. That magical synergy is an interaction effect. For our farmer, it might mean fertilizer A is amazing with low-density planting, but fertilizer B is the champ for high-density planting. The best choice of fertilizer actually depends on the planting style.
All right, theory is great, but the absolute best way to make this stuff stick is by doing. So let's run through a few quick scenarios. For each one, you decide, do we need the basic toolkit or the upgrade?
Okay, first one. A farmer is testing 3 different fertilizers. That's it, just trying to see which one leads to the highest crop yield.
So, what do you think? Which tool does she need? One-way or two-way ANOVA? That's right, it's a one-way ANOVA. The key here is there's only one factor being studied, the type of fertilizer. It's a straightforward comparison across those 3 groups.
Okay, next up. A biologist wants to see how different soil levels, low, medium, or high, and different watering frequencies, either weekly or monthly, impact how tall a plant grows. Look closely at what's being tested.
what's the right test for this experiment?
You got it. This one is a job for a two-way ANOVA. We have two distinct factors, soil level and watering frequency. And the test will tell us about the effect of the soil, the effect of the water, and most importantly, how they might interact with each other.
And one last one for you. A researcher is comparing 4 different medications. The goal is to see if they produce different results in reducing blood pressure.
So what's the call here? What's the right tool for this job?
And the answer is one-way ANOVA. Even though there are 4 medications, they all fall under one single category or one single factor, medication type. It's a perfect case for a one-way test. So let's just boil it all down. The choice is actually pretty simple, but it's super powerful. A one-way ANOVA is your tool when you have just one factor you're looking at. A two-way ANOVA is what you grab when you have 2. But remember, the real upgrade with the two-way isn't just that you get to test another variable, it's that you get to see if they have that secret synergy, that interaction effect. So, the next time you're looking at a problem with multiple groups, you'll know exactly which tool to reach for. You can see the world in terms of factors and interactions. So the only question left is, what complex questions are you going to start to answer?